Okay, on to our next page with number 8. This is where we get into the function evaluation. Our first one says f of x equals -2 times x plus 1 quantity minus 4. Now, this is saying f of x, meaning that our dependent variable x, or f, and our independent is here. So our function, not our dependent variable, I should say, our function relies on this independent variable x. But to evaluate it, it says, hey, instead of x, what happens when I evaluate at the exact independent value of 4? That means we just take this 4 and everywhere we have a variable x, we're plugging it in. So that's -2, 4 plus 1 minus 4. I put this extra 4 back here on the end just to see if I can trip some people up, make some people forget it, or make them get confused where they're plugging a 4 in. Okay? This follows our please excuse or our PEMDAS rules. Okay? Do not forget those golden rules. Inside parentheses first. So we have -2, 5 minus 4. Right here is going to become a -10 minus 4, which is -14. Alternatively, once you figure out where you're plugging it in, you can just do all of this in the calculator. Okay? Our function is -2, and notice we're on the home screen now, so I cannot use the x. But that's okay, I don't want to use the letter x. I want to use a 4 there, because it tells me what to use. Plus 1, close those off. Minus 4, press enter, and you get -14, just like we said. Okay? Number 9, for the function f of x equals, and this is a quadratic. Little review there. Highest term is squared, that's quadratic. What does f of x equal given that x equals -3? This is the easiest way these problems can be done, guys. This is literally telling you that x equals -3, so you're just plugging that in. This is as easy as they get. That would be -3 quantity squared. Notice how I wrote that. It's exactly how I'm going to type it in the calculator if you want to do it that way. Plus 5 times -3 plus 4. Okay? It's a -3. Got a little weird there. Let's do this by hand, then we can check it in the calculator. -3 times -3. Negative times negative is positive, so we get 9. Okay? This 5 times -3 becomes a -15 or -15, and then plus 4. There will be a fourth option for this. I just haven't created it yet. 9 minus 15 is -6 plus 4. And -6 plus 4 is -2. Okay? So when x equals -3, our function, or our y value, is -2. This means that somewhere on our quadratic graph, okay, is the point -3, -2. That's what evaluating a function is doing. Don't lose sight of that, okay? Number 10 flips the script on you, and a lot of people have been messing this one up, okay? Be very careful. Notice, in this problem, they say, what is the domain? So we're looking for x of this function when the range, or y value, is 9. Well, we look up here and say, oh, but there's no y value in our equation, so what good is this? Well, we know that y is the same as f of x. So what it is that our left side of the equation, our range, is 9. We replace that over here and begin working the function. Or not working it, but solving it, really. So it's 3x minus 2 minus 8x. I'm going to go ahead and erase this just so people don't get confused, or maybe I can just select it and move it out of the way. Nope. So all we've done is we've copied down the original function up here, and we've replaced f of x with 9 because it said the entire range was 9. So now we're just looking for this x. Before we do any of that, we have got to combine all our x's and numbers and stuff together and then start moving them. We've got to free this one up by distributing. Okay, what we have now is 9 minus 3x. 3 times -2 is -6 minus 8x. Now we have some like terms on the right-hand side. We can combine them. Okay, 3 and a minus 8. Okay, remember we just combined the numbers out front. 9 equals 3 minus 8 is -5x minus 6. Okay, a little shape going here. Now, We're just trying to solve for x here, so we continue on. We've got all our x's together now. If you want to move them to the other side, you can. I don't. They're all together. I'm okay with them being on the right. So I'm going to get everything else away from it. What I mean by that is I've got to get rid of this 6. Well, to do it, I'm going to add 6 to both sides. It's always about opposite operations. Always about opposite operations, guys. When I add 6 to both sides, that one cancels away to be a 0, so we don't write it. We have this negative 5x on our right-hand side, and on the left side, we have a positive 15. And we're excited to see that, guys. We're excited to see that because we know 5 and 15 are multiples, or 5 will go into 15, whichever way you want to say it, okay? So we know this problem is going to work out nicely. To get x finally by itself, we divide by negative 5, divide by negative 5. We get that x equals negative 3. Okay, answer A. Now, what happens if you're thinking you're being clever and you're just mowing on through this and you say, okay, number 10, let me take this 9, let me plug it in for all my x's. Let's see what happens because it's going to be the wrong answer, but I want to show you what happens. 3 times 9 minus 2. So you're thinking, oh, this is just like all the other problems. This is super easy. I got this. Minus 8 times 9. Ooh, and look what I made a choice on this test. It's not the right choice, but it's going to get a lot of people. The correct answer is A. What we just worked out by hand because you have to solve this one. But I'm going to get a lot of people tricked because look what happens. If you're just flying through, not paying attention to the directions, you're going to just plug that 9 in, and when you do, you're going to get the wrong answer. And I'm going to make sure that wrong answer is a choice over here, guys. Okay? So be very careful. I'm going to make sure those wrong answers are choices. Be very careful. Okay?